All right, so this is going through the Unit 1 exam review key, or the answers. So the first question asks you to define different terms. So again, accuracy is how close a measured value is to an accepted value. So that's like how right or correct it is. Precision is how close a group of measurements are to one another. So you can be precise and still have completely the wrong answer, right? Or be really far off. But as long as they're all close together, we would consider that precise. A physical change is a change which alters a substance without altering its composition. All right, so that just means something has happened, but at the chemical level, it's made of the same stuff. All right, so a lot of times we talk about things like phase changes. So if I watch my water freeze into ice, it's still chemically, it's still water. It's just liquid water versus solid water. A chemical change, however, is a process that involves one or more substances changing into new substances. All right, so something chemically has happened. The atoms, the compounds, they're rearranging to make new things. A significant number is just the digits in a number that we actually know. So we have measured them. We can say these ones are significant. We have measured them. So a pure substance is something that at the chemical level is everything is the same. So it can be an element where everything is the same atom or element, like oxygen. Or it can be a compound where it's more than one element. So like water is two hydrogens, both of them bonded to one oxygen. But water, if it's pure water, everything all looks the same. It's all two hydrogens bound to one oxygen. A mixture is a combination of two or more pure substances, where each substance retains its individual chemical properties. All right, so they're not changing each other. There's not a chemical change taking place. They're just coexisting next to each other. All right. So the two types of pure substances that we discussed, element and compound. All right, so some examples of an element. That's anything you can look at the periodic table, right? The two I gave were oxygen and magnesium. You could say hydrogen, any of those carbon, any element. The other type of pure substance is a compound. The two examples I gave are carbon dioxide and water. The two types of mixtures that we discussed were homogeneous and heterogeneous. All right, two examples of homogeneous. So this is where it's uniform throughout. So that's a smoothie, right? You can't tell where the strawberry is versus the blueberry. They're all uniform throughout. And then salt water. Anytime you see salt water, the salt is evenly distributed throughout the water. Heterogeneous means that there are chunks or it's not uniform throughout. It's like a fruit salad. I can go in and pick out the strawberries because they're my favorite. The other example I gave was sand and water. All right, if you have a mixture of sand and water, the sand always settles out. It doesn't stay uniform throughout. So the next was determine if a physical or chemical change is taking place in each scenario. So two pieces of paper are stapled together. So we would say that that's physical because chemically nothing has changed to our substances. The next one, two substances are combined and bubbles start forming. So bubbles are always a good indication that a chemical change has taken place, right? You've created some sort of gas that was not there before. The third one is ice melts into liquid water. So just remember, anytime you see a phase change, that's physical. You're going to think that it's not because it's changing pretty drastically, but it's still water. It's just solid water is becoming liquid water. All right, a teacher instructs her students to measure out 50 mils of water for 3 trials of an experiment. A student measures out 47.5 milliliters, 48.9 milliliters, and 47.2 milliliters. All right, so we're actually going to work this on the next page. So, 47.9, what was the other one? 47.5. 47.5, 48.9, and 47.2. 47.2. All right, so I'm going to work one of these out where you can see percent error. So just remember, it's the measured, so that's what they actually measured, 47.5 minus the actual, so it was supposed to be 50, divided by the actual, 50 times 100. Okay. So just a reminder, the formula for this is actually absolute value of whatever's on top. So that means whenever I go and I subtract and I say 47.5 minus 50, I'm going to get negative 2.5. But because we don't have a negative percent, I'm going to take the absolute value. So as I move forward, I'm going to say 2.5, positive 2.5, divided by 50 times 100 is going to give me 5%. Okay. And so then I would do the same calculation, but I would trade the different numbers in here. So whenever I put in 48.9, I'm going to get 48.9 divided by 50 times 100 is 2.2%. And then, okay, let's do purple. 47.2 will go here. And I will get 5.6%. So those are the 3% errors. So those would go here. So 5, 2.2, and then 5.6. And then you would use them to describe if they were accurate, precise, both, or neither. So just a reminder that accurate, so if it's correct, we're looking at something that's less than, generally, 5%. So these are all about 5% or under 5%. So we're going to say yes, definitely accurate. Precise is if they're all relatively close together. All right, so I don't have any that are 20% or 50%. They're all pretty close together, right? They're all within 3% of each other. So I'm going to say yes, it's precise. So my answer for this one would actually be both. So when you're looking at answering this, you're saying, okay, is it less than 5%? And are they relatively close together? All right, they don't have to be exactly close together, but they need to be within a few percents of each other. All right. So whenever we're looking at significant figures, you're counting and saying, okay, how many of these numbers are not zero? So I have 1, 2, 3. So I definitely have 3 significant figures. And then when you're looking at your zeros, you're saying, okay, what kind of zero is this? So this one is what we call a sandwiched zero. So it's sandwiched between 2 things that are significant. So I would have 4 significant figures. Moving on, I have 1, 2, and then I'm looking at these kinds of zeros. They're sandwiched, so it'd be 3, 4. I'd have 4 sig figs. On this one, I have 1. I look at my kinds of zeros. They are trailing, and there's no decimal. All right, so that means that they are not significant. So my answer is 1 significant figure. With this one, I say, okay, I have 1, 2, 3. And then I look at my zeros. What kind of zeros are they? They're leading because they're before any number that's not 0. So they're not significant. So only those 3 count. My last one, I have 1, 2. And then I look at the 0. It's trailing. There's no decimal, so it's not significant. So my answer would be 2 significant figures. Okay. Finally, we're looking at scientific notation, which is something hopefully you remember from middle school, to reflect the correct number of significant figures. So the way that scientific notation works is I see a number, and if I don't see a decimal, I assume the decimal is at the end. And all that scientific notation is it's a way to put the number that I'm going to move the decimal to where it's behind whatever the first not zero number is. So it'll go behind the 2. All right, so it would be 2 times 10, and then there's an exponent. The way that I know that exponent is I say, okay, how many times did I have to move my decimal to get it behind this number? So, okay, 1, 2, 3, 4 times. So it would be times 4. When we're applying this to significant figures, all you're saying is everything in front of the times is significant. So if I want to make the number more significant, I'm going to add more decimal places. So 2.0, 2.00, 2.000. So it doesn't matter if it's a 0 or not. If it is in front of this x, we say it is significant. And you'll notice that the times 10 to the 4th does not change. Because if you're talking about 20,000, then this will not change because that's just how many times you're moving your decimal back out. Okay? So the only thing changing that shows a changing number of significant figures is how many zeros you're going to put behind the decimal point. Okay? And that is the end of the review. Please let us know if you have any questions.